Hi, in this video we're going to look at the roots of an equation, but it's a different type of equation to the equation that we had before. The equation that we dealt with before was an equation where the roots were real. If I go back and find that equation, we've done a lot of work, haven't we? We're looking at the roots here. Each of those coefficients was a real number. We didn't do any equations there. So we're looking now at an equation where the roots are not real. How do we go about tackling this? Well, it's a difficult looking equation to start off with. So I think what I'm going to do is I'm going to try and take out this complex number that's a coefficient of the z squared term. And in order to do that, I'm going to multiply everything through. I'm going to multiply the entire equation by 1 plus I. And that hopefully will get rid of the complex number that's in front of the z squared. So in other words, I'm going to have 1 plus I times 1 minus I z squared minus 4 times 1 plus I z plus 1 plus 3i times 1 plus I equals 0. Now, don't despair, that doesn't look, it looks worse than it actually is. If I go and tidy up what I've got here now, this is the difference of two squares, so it's going to be 1 minus I squared. Minus I squared is going to be plus 1. So in other words, I'm going to have 2 z squared. That looks a lot better. And what have I got here? I'm actually just going to keep it like this, 1 plus I, 4 times 1 plus I z. And what do I have at the end over here? I've got 1 times 1, which is 1, 3i times I is going to give me 3i squared. So 1 minus 3 is going to give me minus 2. I've got 3i times 1 and I times 1, so that's going to give me plus 4i. And that's going to equal 0. Now, I thought you said it was going to look better, look less complicated. Well, at least now I've got it in a format that looks like a quadratic equation. And since it is a quadratic equation, I'm going to use the general quadratic formula. So you can say z is going to equal minus b. So this is going to be minus that part over there. Remember, b is going to equal this minus 4, 1 plus I. A is going to equal 2. And c is going to equal minus 2 plus 4i. So minus b, that's going to give me 4, 1 plus I, plus or minus the square root of b squared, which is simply going to be this minus 4 times 1 plus I squared, minus 4 times a, which is 2, and c, which is minus 2 plus 4i. And all of that's going to be divided by 2 times a, which is 2 times 2. Whoa! This is looking a bit gnarly. So what have we got? We've got 4 plus 4i. Plus or minus. What have we got inside this square bracket over here? 4 squared is going to be 16. And if I got 1 plus I squared, let's just have a look at that. 1 plus I squared. That's going to be 1 squared plus 2i plus I squared. I squared is minus 1, so it's going to take out the 1 that we've got at the front. So all I'm going to be left with here is 2i minus 8 times minus 2 plus 4i. And all of that is going to be divided by 4. So what have I got? I've got 4 plus 4i plus or minus the square root of 32i plus 16 minus 32i all over 4. And this is now going to give me 4 plus 4i plus or minus the square root of 16 all over 4. And so we now get to a point where we get our solution. Z is going to equal 4 plus the square root of 16, well, that's 4. So it's 4 plus 4, that's going to be 8 plus 4i over 4. And that I can simplify to being 2 plus I. Or it's going to be 4 minus the square root of 16, so 4 minus 4, which is going to be 0. I'm going to get that Z is equal to 4i over 4. In other words, Z is just going to equal I. Now notice here, I've got two solutions, which is what I would expect when I deal with a quadratic. The power is power of 2, so I'd expect to get two solutions. But this time, the two solutions are not the same. They are not a conjugate pair. And the reason for that is because the coefficients of the terms over here were complex numbers. If the coefficients are complex numbers, you will not get a conjugate pair of terms. However, if we look right back at the start, the very first, come on, keep going. The very first example that we dealt with, right up at the top over here, I had an equation that had real coefficients, and I came up with a conjugate pair. So if the coefficients of the equation are real, there will be a conjugate pair. If the coefficients are complex, then you will come up with two solutions, because you must get two solutions to a quadratic equation, but they won't be a conjugate pair. Hope that makes sense to you. Goodbye.